Good evening, friends. Welcome to Eastern Academy. And we are going to discuss about electronics today as a part of embedded system programming. And this is session 1. This session is all about what is electronics. This is a big confusion among the students. What is electronics? Is it a transistor, or it's an IC, or it is a circuit, or it's a embedded or VLSI, or it's a PCB, or it's a board, it's a circuit. What is electronics? There's a big confusion. People have it. So let us first make sure that on this session, that's the most important. Without understanding electronics, working on electronics is wrong. Am I right? So this is what you're supposed to learn when you join an electronics degree in a college. On the first day of your college, you should know about the first day about what is electronics. Understand? That's what we are going to discuss about now. What is electronics? So this whole session is about that. The entire session is about what is electronics. Without that, it's very difficult to proceed further. Let's try to make sure that what is electronics. So we know very clearly this. The last sessions we discussed about a simple voltage source, and we have a bulb or some utilization, and they have a control. And this is a transmission. I. All devices are, whether it's a motor or bulb or heater, everything is resistance. Understand? This is what we discuss. Or so when I put the switch here, if you put a resistor here, then both the resistor will add up, R1 plus R2. So the current will be controlled. Am I right? So then in that case, we call it as a regulator. So this can be control, can be switch or regulator. Let us talk about switch. Let's talk about regulator later. So this is what a simple circuit. Now, what we are doing now is doing a very simple extra concept. The same, we make the electrical into 2 switches and 2 bulbs. Am I right? I have 2 switch and 2 bulb. So there's a 1-to-1 connection. This is switch 1, bulb 1. Switch 2, bulb 2. Now I make one more. I have a switch 1, switch 2, switch 3. 3 bulbs. Just connect it. Now I have a switch 1, bulb 1, switch 2, bulb 2, switch 3, bulb 3. Am I right? This is a quite simple one. It's all very straightforward. We know that they're all parallel. Each switch control each bulb. Nobody will have a doubt. Our house like that only. We have a house. In our house, we have a switch called in hall, in kitchen, bedroom, restroom. We have a switch, and for a fan, for AC. Every device we have a switch. That switch control if it's a hall bulb, kitchen bulb, bedroom bulb, restroom bulb. We have a fan, AC, heater. Every device is having a switch. And the moment I on the switch, the bulb get the rated voltage. Let's say I am applying here 230 volts. That gets 230 volts. Then that's going to perform. This is all about electrical. That's what typically our electrician does. you call an electrician, he will wire your house. Things are very fine. But suddenly somebody thought, hey, I don't want like this. I want S1 to B3, S3 to B2, and S2 to B1. See that? S1 to B3, S2 to B1, S3 to B2. So I called electrician. So electrician came. He did the connection. S1 to B3, S2 to B1, and S3 to. So he changed the wiring. Now what happened? If you have the S1 that controls B3, S2 controls B1. All fine. But later I want to change once again. Every time whenever I change, I need call the electrician. But suddenly I had a requirement. The requirement was slightly different. Please understand. We are discussing about electrical. Suddenly I had a requirement. What happened? When I put S1, B1, B2, and B3, all three have to be on. When I put S2, B1 and B2 should be on. S3, B2 and B3 should be on. Why? You may ask why. Suppose I am coming from outside. I on one switch. This is B1 could be hall. B2 could be kitchen. B3 could be restroom. I put one switch. Then all the three are on. Am I right? When you put S2, then hall and kitchen will be on. When you put S3, hall and kitchen and restroom will be on. So I don't know how to put so many switches. I'll put only one switch. I'll control. Then I called the electrician, and electrician said that he spent some time connecting the thing. Then the electrician said, sorry, sir, I don't know how to connect this. This is not possible. Then the engineers are thinking how to do that. How to do that. They come out with a plan here. They put this as a box. See here, let's assume that if you put it after 230 volts, when you put S1, this box input gets what? 230 volts. S2 gets 230 volts. S3 gets 230 volts. Am I right? And this is what the trick. So when you don't on any switches, you don't get any voltage here. So the engineers found a method. He solved the problem. The engineer come and gave a box to the house owners. Not the electrician. The engineer come and gave a box to the house owners and told the electrician to connect. They told the electrician to connect. This is 3 input, ABC. And XYZ is output. These 3 are input. Assuming that these 3 are input. And these 3 are output. Now we understand what is input, what is output. And our engineer came and gave a box to the electrician, this box, which has 3. Then this gas is supply, 230 volts. So that engineer come and gave a box to the electrician. You connect this box. That would work. Then that worked. That worked. And that engineer said this has one extra feature also. Then the owner has asked the customer, hey, what is the extra feature? He said that you can connect one more bulb, night lamp, NL, night lamp, or put N. night lamp. When all the switches are off, the night lamp will be on. See that? So all the switches are off, the night lamp will be on. So there is one more thing. S1 means is when all are off, night lamp is on. So you forget about everything now. You forget about this. You forget about this, assuming. We draw a box. We draw a box. This box has 3 inputs. A, B, C. 4 outputs. X, Y, Z, and N. Night lamp. Now, when A is 1 and B and C are 0, then X1, Y1, Z1, because all the bulbs will be on. When S1 is 1, B1, B2, B3 will be on. When S2 is on, that means that this is 1 and this is 0. B is 1. That means that this becomes 0, these two become 1, 1. B1 and B2 are 1. This one is 0. Now, this is 0. Now, when S3, when this is 1, then this one is 0, these two become 1, and this is 0. When all of them are 0, this become 1, all are 0. All the bulbs are off. So you understand. Now you're assuming that I connect a bulb here. I connect a switch here. I'm not showing that. When you on the switch is 1, off the switch means 0. Same way, when the output is 0, voltage means 0, 230 volt means 1. That's what I assume now. This block, this block is called electronics. You understand now what is electronics? Electronics takes electrical inputs and it gives electrical outputs. It could be anything. Even sometimes it can be having a direct connection. So I already told you that. If you remember the thing, all squares are rectangles. So a square is a rectangle, but all rectangles are not squares. The same way, now if I connect this directly 1 to 1, then when I put A, the switch 1, bulb 1 will be on. When I put switch 2, bulb 2 will be on. When I put switch 3, bulb 3 is on. Understand? This is a simple electrical, but that is also a subset of electronics now. Please understand. So, electronics, nothing but a block which takes electrical inputs and electrical outputs. That's all, nothing more than that. You may call it indirectly like this. We draw like this. Indirectly, we draw like this. There's a block, takes the input, takes the output. Let us call X is the input, Y is the output. X can be any number. I can be having n number of input. I have m number of outputs. Okay. Now, Y is equal to f of x. Y is equal to f of x. That is what all about mathematics. From that, it came physics. From physics, there are branches. Mechanics, then optics, electronics. Mechanical, optical, electrical. Mechanical, mathematical. Mathematical, sorry. physical, mechanical, optical, electrical. So electrical, all these mathematical things are all, you will call mathematical symbols. You will call mathematical functions, but mathematics is what? Physical devices. We don't call physics devices. We call physical devices. What? This is a physical device because you have it. What you write on the equation x plus y is equal to 5. It's a mathematics. If you put the same thing, let us say y is equal to 4x. This is mathematics. The same thing, I have a lever, I pull it, goes up. If this goes, this is 1:4. If it goes by 1 feet, this will go by 4 feet. So this is physical. So all this electronics, mechanics, optics, all are branches of physics. That's why in the school, first they teach you mathematics. Then from mathematics, they start physics with the application of mathematics on physical world. Then when you go to the next level of engineering, they divide the physics into mechanics, optics, and electronics. So you slowly you become specialized. But very unfortunately, today things have changed. That's the reason we can start directly learning electronics without, you do not have to go to this path. There's a problem there. So please understand, electronics is not about devices. Electronics is not about circuit. Electronics is not about components. Electronics is very simple. Y is equal to f of x. There is a trick here. That please understand here. We have a lot of confusion here. If I define a journey, what is journey? Going from place X to place Y. It's a journey. Understand? Going from place X to place Y is a journey. But you take here, this could be from Chennai. This could be New York. So how do you go? So many things. I go from Chennai to airport, my house, to airport. This is a one journey. And there's one more journey from airport outside to flight. Then I go to Singapore or Dubai. And in Dubai, from Dubai I go to New York. Then I go to take the taxi and go to hotel. See that? See, if you take a top level, there is one journey. This is journey. In between, there is a small journey, J1, J2, J3, J4, J5. These are all journeys. Please understand. So we have a confusion. That's a problem. Now everything is a journey. For example, going from your house, let's take a J1. Going from your house to airport. That is a small thing. From house inside to outside. J11. From outside, you take the taxi. J12. From the taxi, go to the airport. From the airport, you go inside to another vehicle. That's J13. See that? Understand one thing. We have a first thing is journey, J. So let me draw it here. Then you'll understand. So that the first one is journey. Going from Chennai to New York. This is a very top level. Then this has so many things. J1 to airport, J2, J3, J4, J5. Small thing. This one is from house to airport. From airport to Singapore. Singapore to, sorry, Dubai. Dubai to New York. New York to outside airport. Then you take another taxi, go there. Now, if you take J1, that itself is having a 1, 2, 3. So your journey you cannot define. That's a small, so many small journeys together is once again a journey. So if you say that, see here, there's a confusion. J11 plus J12 plus J13 called J1. Then J1 plus J2 plus J3 plus J4 plus J5 is journey, J. So everything is journey. So journey plus journey is journey. Here is a problem you have. That's why people ask today, if you take a single board, okay, there is I have an input, I get an output. This is electronics. I have a board. In this board, I may be having so many components. So many small journeys. Block 1, block 2. Am I right? This all has to be connected. So I have a better block, electronics. The electronics is having so many small blocks. This small block is also electronics. So that's why we have a confusion. We have a confusion is how come electronics plus electronics is electronics? That's a beauty. I hope this is clear. That means that I can have within the board, within the top electronics, I can have n number of blocks, n number of electronic blocks. Each can be connected in different way. Am I right? Now, we come to the next level. To make a journey, let us take a thing. Let us come to the very bottom level now. That is called implementation. You walk from your house inside to outside. House outside. You are using legs because you walk. From outside to airport, okay, you go by taxi. That's a vehicle. The taxi is a vehicle. Then from airport outside, airport inside, you walk. You understand now? You walk, you go by taxi, then you walk. There are so many types of journeys. But we don't call this going by taxi, okay, as electronics. But we know that taxi helps you to fulfill the journey. Fulfill the journey. Am I right? It tried to fulfill same way. You go here from Chennai airport to Dubai. You go by flight. The flight is a vehicle, but that's not electronics. Here legs, which are helping you to walk. The legs are tools or vehicles to help you to walk, go from X to Y. So don't get confused. That's why here we call this block is electronics. Inside, there are small things which help you to achieve the input output. These are called components. Electronic components. Don't get confused between electronic components and electronics. For example, we'll discuss later diode, transistor. These are all called electronic components. They are not electronics. Please. They help you to achieve your electronics, a goal, like a journey, like a taxi or a flight or rickshaw, whatever it is. They are helping you to fulfill your journey. That's it. Now, here is a trick came. What the engineers were trying was the next thing. They want right now in electrical, see here, you have a voltage, you have a bulb, and you have a switch, and this I, R. Now the switch, you control it manually. Okay, you control manually. What the engineers are trying was, they want to control a switch automatically. So this is what they started, control. So we discussed about 5 in the electronics. One is electrical, one is voltage, generation, utilization, measurement, transmission, V, R, I. Then measurement, V is equal to IR, P is equal to VI. Then came was control. Control, we discussed switch and regulator. Regulator is a variable resistor. Okay. Now, in electrical, the switch and regulator are manually controllable. Whereas what people want was, in this control, they want to have a manual versus automatic. What is this automatic control? That means that I control the switch or regulator by applying a voltage. Not manually, not by hand. How do we do that? Okay, the first one was invented. It's very simple. They put a small iron core coil. When I apply a voltage, when I on the switch, this iron core get magnetized. So it is attracting a small iron piece. It gets and comes here. But what engineers did was, they put a spring here. So this cannot come down. It cannot come down up to this place. The spring will not allow you to touch here. Then also what they have done was, they put a stopper here, a metal piece. And this they connected to the bulb. And here they given a voltage. They given a voltage here, they have given a bulb here. Now, if you on the switch, here is a 5 volt. If you on the switch here, it become magnetized. So it acts the switch, the circuit get connected, then the bulb is on. This switch is not manually controlled. So this switch is a automatic switch. But since we use magnet here, they call this as a electromagnetic switch. The short form they call it as a relay. So relay is nothing but an electromagnetic switch. So instead of drawing like this, we can draw it very simple. That's it. We apply a voltage. 5 volt or 0 volt. When I apply 0 volt, switch is off. When I apply 5 volt, switch is on. Understand? This is what as simple as that. So now do you understand about automatic switch? If it is not clear, let me know. So normally we control manually the switches. Now from the manual switches, we move to the automatic switch. Okay. Then engineers are trying to find out the problem here. The problem is this magnet and there's a spring and stopper. So it can be anything, 5 or 12 or it depends on the size of the coil magnet. So it need not be 5 volt. It can be 5 volt or 12 volt or 3 volts or 24 volt, anything. It depends on the size of the coil, how big the switch is connected. Need not be only 5 volt. I've just given a 5 volt because generally we are always saying 0 volt and 5 volt. That's why I say that. The control can be anything. This coil can be anything. Generally in the market, people use 12 volt, not 5 volt. 12 volt is a very famous one used by the industry because that will give you the more magnetic power. The problem is this. This is all mechanical. When I on the switch here, this spring have to be pulled and get connected. It takes time. So it is slow first. Second, so many times when it comes closer, that time there'll be a spark here. There'll be a spark. When there is a more spark, so many times, then that contact get damaged. So the contact get damaged. So sometimes the connection will not be there. And third problem is the spring itself. After 100 times or 1,000 times, when it goes ups and down, the switch become loose. So spring always touch here. So the relay switch is always on. So this is what they call as a wear and tear. Wear and tear. But this one, slow. Anything mechanically slow. So what engineers are trying to find out, instead of this mechanical, why don't we start doing a electrically controlled one? Okay, that means that they don't want the magnet at all. They don't want anything in between. So what they want is electron to control electron. Please, electron directly controls electron. Don't in between. Okay, that's why they gave the field itself called electronics. So that's a beauty. They did a lot of research. How do we do that? Nobody got any idea. So actually the relay was used to construct the gates. Relay was trying to construct the gates and gate, or gates. All gates are used by relays. And IBM started building a computer called Mark I using the relays. Okay. And it's become too slow and it's too big and consume too much of current and voltage. So that time only they have had a big problem. Our man, two people have found out. Graham Bell. Graham Bell invented the telephone. And Marconi invented radio. So two inventions. Am I right? So people are trying to find out how to control these things. So that time there's a great scientist called Fleming. Fleming. He used the bulb. We know that Edison bulb, incandescent bulb. It's a very small thing, but made a great thing. So just only one day, you learn it and forget it. I'm telling you how electronics came. So engineers have found out that if you want to achieve electronics, they need electronic components. So actually people in initial days walking. Then only they found a cycle and everything when the wheel was invented. Like that Fleming did an experiment. We know that if I give a voltage here, the bulb will glow. If I cut the wire, what will happen? That's what Fleming did a research. And this one is vacuum. Inside is vacuum. Now, when I cut the connection, the bulb was off. Then Fleming was thinking that when there's a vacuum, why the electrons are not moving through that? Then only he found out that the electron to get out of the wire, there is a force has to be given. What force I will give? Then he little bit changed the box. The wire, he connected two wires like this. This is vacuum. This is vacuum. Now he has collected here positive and negative. There's a bulb here. The bulb was off now because there is no connection. But Fleming is very clear. If you push the electron out of this guy, and this guy is a positive, he will attract and it will go. But how do you push? So Fleming put a heater here. Heater. The heater is the one which pushes the electrons out. Then the electrons are attracted by this. This is going like this. But if you move two other way, if you connect the thing like this way, then this is negative. And this guy pushes electron also. This guy also push the electrons, no current. See, understand here, I need to connect only one way. If you give this is called, they call this anode. And he called this as a cathode. So if you connect anode to positive and cathode to negative, then the current was flowing. Then the bulb was glowing on. But when I change the connection here, when anode was given negative and cathode was given positive, then there is no current. Am I right? You understand now? This is anode and cathode, that's the only thing. So this is what they call as a, since there are two, anode and cathode, they first call it this as a diode. And this one is vacuum tube. So this is a vacuum tube. So this is the first electronic device we think. And it was very, very well used to do, you know, that the use of this one is too good as a rectifier, converting from AC to DC. This was a very famous one that we'll see later, not now. But somehow engineers were not very happy about this. And they were trying to find a device by which this don't have any control. But if you connect the one way, the bulb is going to be on. If you connect the other way, bulb is going to be off. Where is the control? Then there is a great person called, like a Fleming, Lee De Forest. Lee De Forest is the one who put in between this anode and cathode a small grid. Grid is like this. There'll be a small grid with holes. It will be like that. This is called grid. Grid was placed between anode. This is called grid. So between anode and cathode, I may be boring, but still only one day. From tomorrow onwards, from next session also, things will become different. Please. This was invented in the year 1906. This is called triode. Because anode, cathode, and grid, there are three. That's what they call triode. And generally, fairly, they have defined. This is the year of starting of electronics. The first electronic component was triode. Even the diode we use, okay, that is not considered to be electronic count because we don't have a control. Control is not there. Whereas here there's a control. How? If you give here minus 5 volt, so this guy never allow the electrons. If you put the battery like this. If you make this guy as a 0 volt, then there's no effect. All the electron will flow. Bulb will be on. So by making this a minus 1 volt, less electrons, bulb will be slightly dim. If you make it to minus 2 volts, because electron will, negative will repel the negative, electron will repel the electron. So because of that, but at 1 voltage, when I give minus 5 volt, it stopped all the electrons. So current becomes 0. So bulb is totally off. So people have found out that this, they put a symbol like this. They put a symbol like this. This can act as a switch. That is, if you give 0 voltage, it is on. If you give minus 5 volt, it is off. Because it stops everything. In between 0 to 5, this guy will act as a variable resistor because it changes the current. Whatever changes the current is nothing but a variable resistor. So this device, this vacuum tube, triode, act as a switch or thing by controlling the grid. So we have discussed that in the electrical circuit. We have a switch and there is automatic control. Now they got it. And this is the one which helped, as I mentioned to you in the beginning. This is the one which helped the two people, Bell, Graham Bell, and Marconi, to find telephone and Marconi to radio. So Marconi did everything wireless and Graham Bell did everything on wired. Both are doing same thing. Both are doing same thing, but this is wireless, this is wired. What they have done was, the telephone, I transmit at one place, I convert my voice to electrical and transmit. In the other place, they convert the electrical to voice. This is what they did. What Marconi did was, at one place, I convert the voice to electrical. But he transmit through wireless. The other side, he convert this electrical signal to voice. Both are the same. But one place is wireless, other one is wired. What happened was, in this case, since this guy is transmitting, we receive more people. So there'll be only one transmitter. There'll be many receivers. Like your TV. Like your TV, one company is transmitting, and all the others, if you take a CTV, they transmit and all are receiving. But whereas in the phone, two-way communication. So two-way communication. Whereas radio was actually one-way initial days. Only later they found out how to make it as a two-way. That's why you are doing nowadays Wi-Fi and everything. Now I'm telling you that why these things came. What happened when I send it the wire the faraway place? They got a big problem. What is the problem? My voice get reduced here. That is the electrical signal. If here it is 3 volts or 5 volt, when it travels here, it becomes 1 volt. The 1 volt, when I try to convert it to voice, it becomes too feeble. It is too low amplitude. So they were trying to make, they're trying to make a beautiful system. That is, the signal is getting amplified. The signal is getting amplified. How? How? We will explain it after about a 5 minutes break. Because I have to start from scratch that one. Okay. So please understand what we discussed so far. Okay. After about 5 minutes, I will come and explain to you about what is this amplification all about. Then we will move on to the next component. That will make you lots of interesting things. So what we discussed for a few minutes, think about it.